This question says, green plants use light from the sun to drive photosynthesis. Photosynthesis is a chemical reaction in which water and carbon dioxide chemically react to form the simple sugar glucose and oxygen gas. What mass of simple sugar glucose is produced by the reaction of 7.73 grams of carbon dioxide? So here we're going to be doing something called stoichiometry, and stoichiometry is incredibly useful. You could imagine, for example, if you knew the mass of glucose that a plant produced by measurement of some type, you could figure out how much carbon dioxide that plant took out of the atmosphere. So this can be incredibly useful. Or if you work for Bayer Aspirin Company, and aspirin's made from salicylic acid and acetic anhydride, you would know how much salicylic acid and acetic anhydride to order for the specific amount of aspirin that you want to make. So stoichiometry is incredibly useful, but stoichiometry always starts in one place. Always, 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 when you're doing stoichiometry, you need to start with a balanced chemical equation. And here they don't give us the states of matter for the water, the carbon dioxide, the glucose, and the oxygen, although we could make an educated guess of what those would be. I am going to ignore them here. So here we have H2O reacting with CO2 to form glucose, C6H12O6, and oxygen. So this is our chemical reaction. But as you know, we can't just leave it here because now we have stuff appearing and disappearing, right? We have one oxygen on our reactant, or excuse me, one carbon on our reactant side and 6 of them on our product side, and we know that's not okay. So starting with carbon, because this is kind of like a reversed combustion reaction, if we start with carbon here, we can see that all the carbon dioxide goes into glucose. So if we make if we use 6 carbons in glucose, we needed to use at least 6 carbon dioxides. So my first best guess is 6 CO2. You'll also notice that all the hydrogen in water also goes into glucose. There's no hydrogen in oxygen in the oxygen product. So therefore, if we have H12 over here, we must have 6 waters, because each water contains 2 hydrogens. So again, these are just my first best guesses. This gives me 6 oxygens plus 12 oxygens for a total of, on the reactant side, 18 oxygens. However, on the product side, there are already 6 oxygens in glucose. So now I need to figure out how many O2s there are. So if I take 18 minus 6 oxygens that are already in glucose, that leaves me with 12 remaining oxygens. Since this is O2, I need 6 of them. I now have a balanced chemical equation. It is very important to remember that stoichiometry always starts with a balanced chemical equation. Now we want to find what mass of simple sugar glucose is produced by a reaction of 7.73 grams of carbon dioxide. It is not explicitly stated here, but it's important to note that we must have plenty of water present because we need to know that carbon dioxide is the limiting reagent. So here we're going to go ahead and assume that we have plenty of water present, and we can figure out how much glucose we can make using all of this carbon dioxide. So let's do a plan of attack. We want to go from grams of CO2 to moles of CO2. We can then use the balanced chemical equation, and this is new for things you've done in ALEX previously, possibly. So once we have moles of CO2, we can use the balanced chemical equation to figure out how many moles of glucose we can make from those moles of CO2. We can't relate grams of CO2 to grams of glucose directly, but we can relate moles of CO2 to moles of glucose directly. After we have moles of glucose, we can go to grams of glucose, C6H12O6. So this is basically our plan of attack. Now, you've gone from grams to moles and moles to grams many times. So the only new thing here is moles to moles. So to go from grams to moles, we need to use the molar mass. So in this case, we're starting with 7.73 grams of CO2 times, we want to put the molar mass on the bottom, which we add up carbon and 2 oxygens from the periodic table, and we find out that that's 44.01 grams of CO2, and on top 1 mole of CO2. because this is the mass of 1 mole. Remember that all of these come from equalities. 1 mole equals 44.01 grams. Do not use the stoichiometric coefficient when converting from grams to moles or moles to grams. Times. We now want to figure out how many moles of glucose we can make with our moles of carbon dioxide. And for that we have the balanced chemical equation. For every 6 moles of carbon dioxide we react, we make 1 mole of glucose. So on the bottom, we put 6 moles of carbon dioxide. 6 is the stoichiometric coefficient, so that's where that came from. We put CO2 on the bottom, so it'll cancel out. On top, we put 1, there's no 1 shown there, but it's a 1 mole of glucose, which is C6H12O6. Now finally, we want to convert from moles of glucose to grams of glucose, and you've done this before. We put 1 mole of glucose on the bottom, and on top it's molar mass, which we just add up 6 carbons, 12 hydrogens, and 6 oxygens, and that comes out to, in this case, 180.18 grams of glucose on the top. And that gives us our dimensional analysis formula. Now, due to space limitations, I am going to write the answer down here. The calculator tells me 5.2745526 and some more digits. But in this case, I have 3 significant figures in this mass. And although molar masses are measurements, dimensional analysis conversions for moles of this to moles of this are defined equalities and they're not measurements. So therefore, we are going to go with 3 significant figures because both of our molar masses have more than 3, and we shouldn't limit ourselves by the molar masses anyway. So we need 3 significant figures because this mass has 3 significant figures. So that's that digit, and we end up with 5.27 grams of glucose, C6H12O6.